In this video, we're going to take a look at how to graph the tangent function. So if you recall, the tangent of theta is equal to the sine of theta divided by the cosine of theta. And with respect to the points on the unit circle, that's going to be the y-coordinate divided by the x-coordinate. So let's take a look at graphing the tangent function using the values of the unit circle. Now, in order to graph one full period of the tangent function that's continuous, we need to graph from negative pi over 2 to positive pi over 2. So that's going to be the values in the fourth quadrant in the negative direction, and then the angle measures in the first quadrant. So if we're looking at 0 radians, we take the y-coordinate divided by the x, 0 divided by 1, and that gives us a value of 0. So at 0 radians, we're going to have an x-intercept. At pi over 2, we have 1 divided by 0. 1 divided by 0 gives us an undefined value. We're not allowed to divide by 0, and results in a vertical asymptote. So at pi over 2, we have a vertical asymptote. At negative pi over 2, we have the same thing. Negative 1 divided by 0 gives us undefined value again, and we have a vertical asymptote at negative pi over 2. So the cycle of the tangent function is bounded on either end by a vertical asymptote. Halfway in between, we have an x-intercept. Now, if we wanted to, we could get really specific and graph like at pi over 6 and pi over 3. But just like with the sine and cosine function, we're only going to look at like 5 key points or features. And to do that, we're going to use pi over 4 and negative pi over 4. The reason why we're using pi over 4 and negative pi over 4 is because they give us nice values. When I take the y-coordinate divided by the x-coordinate at pi over 4, it's square root of 2 over 2 divided by the square root of 2 over 2, which is 1. So at pi over 4, it's going to be 1. And then at negative pi over 4, it's going to be negative rad 2 over 2 divided by positive rad 2 over 2, which is going to give me a negative 1. So those are going to be, these are the 5 points and features that we need to look at when graphing. So our 2 vertical asymptotes, those are on either end of the period. Halfway in between, we get an x-intercept. And then halfway in between the x-intercept and the asymptote, we get the hitting our positive a value and then hitting our negative a value. So then you just fill in your curve, and then you've graphed one cycle of the tangent function. So that's one cycle of the tangent function. As you can see, it goes from negative pi over 2 to positive pi over 2. And so that gives us a period of pi, and we've seen that before. And because it has a period of pi, we can graph another cycle just by moving to the right and left pi units. So if I go to the right pi units from 0, I end up at pi. Here we'll be at negative 1. Here we'll be at positive 1. And it will look something like this again. And we could do that in the negative direction. So at negative pi, we'll have an x-intercept. 3 pi over 4, we'll have a positive a value. And then here, and then graphing another cycle. Now, the tangent function when a is positive is always increasing for every value on its domain. And then it has vertical asymptotes at all of the odd values of pi divided by 2. All the odd values of pi divided by 2. So let's take a look at graphing the cotangent function. So the cotangent function we know is the reciprocal of the tangent function. So in the background here, you can see kind of transparent, I graphed the tangent function. And so we're going to use that as reference to graph the cotangent function. So here we have an x-intercept on the tangent function, which was the result of taking 0 divided by 1. So if we take the reciprocal of that, we get 1 divided by 0, which is undefined. So we get a vertical asymptote. So anywhere that our tangent function had an x-intercept, it's going to result in a vertical asymptote. So we have a vertical asymptote there. There's another x-intercept. We're going to have a vertical asymptote there at pi. Where there was a vertical asymptote in the tangent function, we know was a result of 1 divided by 0. So if you take its reciprocal, it's going to be an x-intercept. So vertical asymptotes turn into x-intercepts. X-intercepts turn into vertical asymptotes. Here at pi over 4, its value was 1. So take the reciprocal of 1, we get 1. And then at 3 pi over 4, it had a value of -1. Take the reciprocal of -1. 1 divided by -1 is -1. So it's here. So that's, and then it kind of just looks like a mirror image of the tangent function. So it's going to look something like this. This is the cotangent function. And you can see that as it says, one cycle from the cotangent function goes from 0 to pi. So it starts at 0 and goes to pi. And that's because of the way that we're using the values of tangent to find the cycle for cotangent function. So here's the general form. Y equals a times the tangent of omega x plus b, and a times the cotangent of omega x plus b. A, b, and omega still have the same effect that they do in the sine function. However, there's no amplitude for the tangent function because there's not a maximum or minimum value. So what a represents is just the vertical stretch of our function. And also we know that the period for the tangent and cotangent is pi. So in order to find the period, we use pi divided by omega rather than 2 pi divided by omega like we did for sine and cosine.